Alright, so something happened on my previous recording. So we're going to make a part 1 and a part 2 for week 3. So this is part 2, and just to recap, 2,000 pounds per square foot. Alright, 2,700 to 20,000 degrees. We've seen a video. So now we're going to watch another video. It's all from an arc flash, obviously, okay? Remember? So we'll watch this one now. Nice and noisy, right? Wake the dead up. That's what it's designed to do. So it'll be a mad scramble to get this looked into and put under control, obviously, right? The worst enemy offshore is a fire on a ship or an installation. Don't get it contained, you gotta abandon ship. Alright, so there we go. So now we got the limb circuitry. Alright, lawn insulation monitors. So know this red one here, very tricky multiple choice, might be coming at you one of these days. The main reason that limb or ground fault circuit interrupter circuitry, ground fault card, interrupter circuitry is used is to protect personnel and equipment. It is intended to give an alert, light and sound, and or disconnect the power supply when the impedance between the two conductors drops below a set value, usually 500 kilo ohms, right? 500,000 ohms. Limb circuitry monitors the system for electrical leakage and can de-energize certain circuitry when it detects a resistance or impedance value that is slower than what is considered normal or safe. So continuing on with the limb, 6 main surface power circuits being monitored on a typical work class 3 ROV such as the Millennium. Once again, that's the in-between, alright, between a MAG and a maximum oceaneering vehicle only. Incoming system power, so the 480 VAC 3-phase, alternating current for those who just tuned in. The vehicle electronics power, 480 VAC single phase, and TMS electronics power, 480 VAC single phase. Okay, so that's the before it stepped up. Okay, that's not going to what's going to go down into the ROV and TMS. It's all going to be stepped up. You can see it here. It's stepped up the motors for the TMS motor, number 2 and number 1. And usually if I'm a bet man for being aircraft, the number 1 engine is on the pilot side, should be the left. So that would be the port motor and the starboard motor. But who knows. So anyway, it went from 480, stepped up to 2300, right? This is incorrect. 480 and 480 here. The incoming system power stepped up for the single phase to, like, 1200, 1500, 1800. Okay, single phase, or whatever the manufacturer just specs out. Could be 1000, whatever model is being built by whatever manufacturer. But you get the gist. 3-phase for a motor is going to be more than single phase for the electronics. All of it, this is stepped up from the ship's power, incoming system power. That's as clear as I can make it. Lawn insulation monitor, limb circuitry again. Insulation resistance of the umbilical and high voltage lines is monitored with one or more multiple limbs. So insulation being the covering of the wire, right? If that breaks down, you'll have a ground fault, a leak. The limb shuts down high voltage outputs by de-energizing the contactors by use of a relay board in the event of an insulation fault. So an insulation fault could be like, bend radius. You'll hear me say that in 2 or 4 years constantly, depending if you're doing the 2-year course or 4-year course. And, insulation gets bad. Supposedly, the Peggy's Cove air disaster, Swiss Air, was a bad bend radius up in the cockpit. So it was crinkled on one side, if you can imagine. If I'm just making an arc here, so the inside was crinkled, the outside was stretched. One of them on whatever side was after busting open, so you had exposed metal. Condensation dripped down, hit the wire, created an arc like you seen earlier. Caught on fire behind the panels, right? There was insulation that was supposed to be fireproof, but I do believe the heat was so intense it caught it on fire anyway. Pilot or co-pilot turned a fan on to blow it away, not knowing what it was supposedly, and that fanned the fire and caused that disaster. So supposedly it took them 2 years and over 2 million pieces to piece together that, and that's what they come up with. Alright, so insulation, remember it. Lawn insulation monitors again, circuitry subsea now. Limb or ground fault circuitry is also incorporated in the control van electrics, in particular the 480 VAC incoming system power to the PU. Sense resistors are located from the secondary side of the power source to the primary side of the load or step up or down transformers. Therefore, any leak between these points will indicate a leak or ground fault. Note that ground faults on the primary side of the power source cannot be detected and must be monitored separately. Limb units are incorporated into the subsea vehicle and TMS as well, but usually only perform monitoring function for the low voltage components. So the 120 VAC. So your electrics will just go back now. So you're seeing 120 VAC down in the sub and the TMS. Once the 1400, 1200, 1800 VAC single phase goes into the term cans or on an XL Perry Slingsby vehicle, a power can, so that's a termination can, and a step down transformer. Alright, it got to go down to the transformer can. There's got to be a step down transformer because the electrics ain't going to work off 1200. Alright, it's going to go back to the 120. So hopefully I'm not confusing you. So just remember that. Step back down, not for the motors, only for the electrics. Okay, step back down to 120. Then it's rectified, and there's 24. Okay, and then that's rectified to 24 DC, and then you got your DC converters that gives you the 15, 12, and 5 VDCs. Okay, they cannot automatically be shut off by means of relays or contactors like the surface ground fault systems. The operator is normally responsible for shutting off these individual outputs or recovering the TMS and vehicle to service to troubleshoot if deemed necessary. Minor ground faults are usually water ingress related. Limb systems have to be tested on a regular basis to ensure they are functioning correctly and therefore protecting personnel and equipment like they are designed to do. Right, so it should be some type of preventive maintenance program. Alright, preventive maintenance is the best maintenance. Get you an idea on where things are to and how to fix them, how to disassemble and all that before it actually breaks down, and then you're like a newborn trying to run. Okay, so here we go again. Here's a limb system. Test override switches. So this will show you briefly, right? But there is an oceaneering procedure to get inside this panel and to safely disconnect the wiring that you got to do to understand it. How can I say it? And to work safely around high voltage, even if you're, from the streets, okay? So you can be trained. They put monkeys into space, didn't they, at one time? Okay, so Here we go. This is inside. Now this is during the a D-Tech ground. So this is oceaneering once again. Ground fault card in a power tray. So this would be underneath the pilot's console. Now this is back in C-Tag days. I'm not going to get too much in this because it might be obsolete right now. But do note, you know, your card. So what I'm going to say here, relays here, right? You know, look at all the nice bend radiuses. Everything's tied up. Important that these tie wraps are cut flush. So when you stick your hand down in, you don't cut yourself, spreading disease and getting infected. So see how everything's nice and neat, right? What else about this? As a new hire, you would go down on your spare time to the inventory in the work van, and you would familiarize yourself with these cards, okay? And or as another student from a seismic ship told me, which is a good idea too, on the cabinets you would have pictures of like a relay card or whatever, okay? The 8-channel ground fault card, stuff like that. So that you can you wouldn't be spending 10-15 minutes looking through bags, anti-static bags protecting these, looking for them, okay? So you got to be able to identify what the card is, because speed is of the essence, okay, to get stuff fixed offshore. It used to be $6 a second back in 2005. That's what the rate cost or something, right? So I'm sure there's a lot more than that now. So once again, right, this is a relay card for power tray. Deactivates contactors. Sorry about the wiggling. And that being said, let's do this. There we go. That's better. And that being said, right, just familiarize yourself with it, okay? If you're still using this. Makes sense what I'm saying, I hope. So here we are, control van, power PDU again, right? So 120 VAC switch voltage is coming in your relay. As you can see, the flow, right, goes in and out of your ground fault monitoring card. Like I said, 1, 2, 3, 4, 5, 6. Really left to right on your pilot's console. Right, so that would be like another console power would be another name on this if it was in front of you. Then you got your cage electrics, vehicle electrics, cage motor, vehicle port, so I was right, and vehicle starboard. Alright, number 1 engine. The pilot sits in the number 1 seat, left side. Okay, so just remember that. The ground fault monitoring circuit. The circuit has control over the control voltage for energizing major power loads. When a 500 kilo ohm ground fault is sensed, the voltage is dropped out to the corresponding circuit. Alright, so it shunts it to ground here. That's what they're trying to say. This is the ground, Mother Earth, whatever you want to call it. Alright, instead of going into this and creating a screw up, it goes to ground. Control van again. The control console is the interface point of the operator with the TMS in the vehicle. The control console contains the bulk of the control and monitoring hardware for all ROV operations. A bank of monitors presents all the two-dimensional data coming from the subsea and from the vessel and vehicle navigation system. Alright, so that's it for this presentation, but I got some other stuff to add. Alright, so we're going to hit this. And here you go. Here's your 17 block diagram. Know it. So, they're saying 460, okay? So, you know, I'm not going to be a stickler on that. Depends on probably what ship. What we've seen from the MG generator. Into control cabin PDU, transformer cabinet, 460 or 480, right, what we've seen. Stepped up, they're saying here, for your electrics, 2800 single phase, okay? This is not the gospel. This more or less is the gospel, these blocks. What's in them, like the voltages, depends on the manufacturer. 2 times 2800 VAC 3-phase. Alright, so that's for your motors, electrics. Remember, it got stepped up into this. And remember, this gets stepped down, single phase. And we got the 110. Okay, so there's a step up and a step down transformer here somewhere, obviously, because it's getting stepped down 460 to 110. So that's for your control cabin, right? That's domestic, your heat, your lights. Alright, so that's straight on through. Over this way, another line comes off of your ROVs and that. Deck lead, right? Got all the heavy wiring in it. Into the winch, think on the big drum with the armored umbilical. Fixed junction box into your slip rings. And we'll get into all these in the following weeks. In your winch rotating junction box. Alright, so now see the colors. All white. This is where, so your umbilical's coming out now, the mile long or 2 miles, whatever, the armored umbilical. So the surface stops here. Make sense? All the white is the surface. All this is subsea. And this is broken down into your tether management system, the cage or the top hat. Once again, TMS termination junction box, just like the winch fixed junction box. TMS slip rings rotating, junction box flying, tether. Alright, so they condensed it. So that would be a repeat of this and this, right? The slip rings and the winch rotating junction box. So it's a repeat. This is where your yellow, we'll say the yellow tether, 500 meters or more. So now the submarine flies out. Now, going back to the termination, the single phase, which they're saying here is 2800, goes into a step down transformer. Single phase step down transformer back to the 120. The 3-phase just runs straight in. It goes to a term strip, and then you know, A to A, right? Green to green, black to black, whatever, runs off and goes into the 3-phase to TMS electric motors for a hydraulic pump. Straight into your motor. Alright, so that's the 2800 3-phase. No stepping down, no nothing. Straight on through. Electrics, straight on through. I must have went the other way. Straight on through. But step down. Okay? So that takes care of all the electrics and the motors of the TMS. Alright, so this is the TMS. See this freaky color, like this spotted gray? Now, your tethers here hit your ROV termination box. Repeat, right? Of the fixed junction box. Now, there's no drum on this, so that's it. Like I said, now with some models, there might be a step-down transformer in this termination. Alright, so once again, the single phase only, gets stepped down to 120, hitting the MCP, right? Main control pod, main electronics pod, the brain, the CAN, whatever. That's where all the computers are. And 24 and 120, right? And 24 is rectified to 24 DC, and you know, then you got your DC converters, 5, 12, 15, whatever, right? So you got your vehicle system functions, right? 110 for lights and all that, and your 24 for your computers and sonar and camera and all that, and the 5, I guess, for 5 volts for the cards and all that. So your term box, so this was only the single phase. Hopefully I'm clearing it up, not confusing you. And the ROV termination junction box, once again, the 3-phase runs straight on through. So the 2800 comes over, up, in here into the term box, right? It's just a termination box. All the wiring hits term strips, okay? Term strips is like 2 lugs on each side with little separators. And so this is just a straight run, more or less a straight run, straight to the motor. Alright, that's as clear as I can make it. Any questions, email me or ask me when you see me, whenever that happens. So hopefully that breaks it down. I find block diagrams the easiest. Some people are rating the schematics. You know, you got to know schematics too, but as you can see, right? Surface, sub-C, and sub-C is broken up into the TMS and the ROV, right? And this is the main computer inside. So that's as good as it gets. Now then, let's just pause this for a second. So here's another picture, right? What I was talking about, console power, right? Cage electrics, vehicle electrics, cage motor, port motor, starboard motor. All right? You can read all that yourself. I'll get you a couple more pics now. We'll pause again. All right, so once again, we'll just see this. I went to record it yesterday. I'm not sure if it is in it. But anyway, this is inside a PDU, right? And like, once again, familiarize yourself with what each looks like, right? Your circuit breakers, your contactors. When someone tells you, just say you had to replace that, and you had to go downstairs, you're new, don't bring up the circuit breaker, right? Bring up the right component. That's what I'm trying to, right? Megacon adapter. Clearly a difference in this and that, as in this, this, and this, or this, 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 and that. Right? You can clearly see all the differences. So just know all that. So for your new hire, you're going to be monitored, mentored. You should be, right? For at least one hitch, maybe 2 or 3. That should be really it. And then you're on your own. So be an eager beaver. Look busy. Be busy. Be inquisitive. Don't be afraid to speak up, especially about safety. And show enthusiasm. And, hit the books. Hit the drawings. Make your own drawings in block diagrams. Right, to divide stuff off, half it up, right? Half it up like surface sub-C. Okay? Then, like, if it's surface inside the control van or outside. Makes sense, okay? Sub-C, is it the ROV or the TMS? Just, basic approach to troubleshooting, right? Keep halving it up and you'll eventually get to the right. So, so you half this up here. We know it's, say, a bad circuit breaker, whatever, we'll just say. Right, so you halved it up. Now it's in the control van. Then you half that up. You get in the PDU. Then you half that up. Okay? And you half that up. You half that up. And you half that up. And next thing, you're down into the circuit breakers. Okay? So that's what I'm trying to tell you. There's some other, what a varoresistor is. This is what I was showing you earlier. You can read all that yourself. You can pause it. This tells you about the breakers. Right? The cage electrics cannot be energized until the console power is enabled and the contactor is energized. I explained that earlier, so, there you go. All right? Clear as mud for everyone. Email me any questions. Over and out.